Hi, I'm Nicholas Mendez, organizer of GDG Postmate, and welcome you to for, I'd like to welcome you for joining us today for Chrome Dev Summit Extended 2020. So without further ado, let's get into it. So the Google Chrome Developer Summit is a yearly event held by the Chrome Dev team. And it's about sharing the new and exciting features coming to the Chrome browser and the wider web platform. Extended events such as this one give an opportunity for local developer groups to be part of the event and allow for further learning and exploration of the topics covered. So today, I'm going to talk about a couple of things. I'm going to cover something called Web Vitals, UX patterns optimized for core Web Vitals, SMS OTP. We're not really going to cover the stories right now. That's an error, but we're going to after we will talk about what's new for web apps in Google Play and next level web apps on desktop. We'll also have a sort of some demos and code labs, and then we'll call that a day. So first, let's talk about UX patterns optimized for core web vitals. So when a user visits a website, they have certain expectations. They want to see useful content and interactions that are smooth and predictable. But as developers, we try different UI patterns to meet the expectations, but we also have these business needs. We need to cover things like carousels and ads, footers. So it's a funny balancing act where we're trying to achieve the business goals, but still want to give a good experience for our users. So great experience is intangible. It could be difficult to measure. So one way in which the Chrome team sees in measuring these metrics is by answering three questions. Is it happening? Is it responsive? And is it delightful? And these metrics closely relate to these three pillars that the Chrome team calls the core web vitals. And they are the largest contentful paint, corresponding to loading the first input delay corresponding to interactivity, and cumulative layout shift or CLS corresponding to the visual stability. So after research of millions of pages using projects such as the Chrome User Experience Report, the team have found that if a site meets these core web vitals, users are 24% less likely to abandon that page. So let's talk about the different patterns that we see and how they can be handled to deliver a good experience. So when a user visits a page and then a user navigates to the site, the static content may be rendered first. However, if you need to show up a promotional banner, you've probably seen this before, whereby the content at the page actually shifts to show that banner. Nowadays, we're increasingly seeing addition of informational ballots related to COVID causing further shifts, and this overall impacts the CLS metric of the page. Quite simply, you just want to avoid this, and the golden rule is to avoid shifts in the active viewport. So if there are things outside of the viewport below, that's okay if it shifts, but if it's the first thing the user sees, you really want to avoid that happening. And ways you could do that is just simply creating a fixed height space for that content to be loaded in afterwards. Therefore, if the user is already reading things, it won't shift when those banners or when those ads are loaded. One way of doing this is the min height CSS attribute. However, if the content is larger than that, you will still get some shift. There are certain techniques you can use to figure out what is the right min height. And it typically has to involve things like analytics and looking into history to see what sizes have been rendered in these placeholders and adjust the min height according to usage data. Some websites opt to use overlays. However, you can still have some scrolling, shifting happening due to unpredictabilities in the layouts, in the sizing of the viewport. Another way these shifts can happen is if you were to show an ad that no longer, that has been collapsed or is no longer relevant to users. So when you want to hide the ad, content shifts back up. One way of getting around that is simply put in some kind of replacement content to avoid the shifting. So Prisma Media is a French publisher website. Using the techniques mentioned before, they were able to drastically increase their CLS, improve their CLS score. The user aspect ratio to determine the image placeholder size for responsive images, and also added textual content and small iconographies to help the user easily identify advertising spaces. Next, we look at dynamic content that's injected as the user scrolls. Under scroll infinite scrolls using the load more button by itself do not initiate any layout shift. The issue arises when you do not have placeholders for new content being injected. So the experience may look like this. The user scrolls down, the footer becomes visible above the fold. Then new content is injected above it, causing the footer to get pushed down. This individual shifts in infinite scrolls can add up to leading to poor user experience and a poor CLS score. This experience can seem like reaching end of a maze, only to realize you have more or multiple rooms to navigate. So you can mitigate it by reserving enough space for content before the user scrolls to that part of the page. You can use skeletal UI placeholders. Remove the footer from the bottom of the page for infinite scrolls, or prefetch the data and image for the brief load of full content so that by the time the user scrolls out for it's already there. So next we look at dynamic content injected on a user click. When a user interacts with the page, they expect the response to be instant. Users will not wait and keep guessing, did that work? Did anything happen? If the response to the click results in a layout shift, it adds to the already poor experience. These interactions are critical to your business because if you want your users, because you want your users that have an attention to, you want your users has an intention to convert. You want them, if your users has an intention to convert, you want to give them the ability, you want to give them timely feedback, as opposed to sticking and possibly losing them. So if you know beforehand that an interaction will take time to respond and will cause some layout, then you can provide instant feedback to the user that you're processing the request. So they will know that, yes, the request isn't quite ready or finished, but you can still give them some kind of visual feedback to know that something has in fact happened. So that when that content actually comes, it is not introducing any layout shift. It's important to note that you have about a 500 millisecond from the user input to make any layout changes that will not affect the CLS score. If you're server rendering the HTML, consider making the initial state render with all the buttons and controls disabled. So if those buttons and controls require JavaScript to work. So when the JavaScript is finished downloading, then you can remove the disabled attribute and then allow them to be clicked. NDTV is one of the largest media companies in India, prioritized the largest content block by delaying third-party requests and saw an increased engagement and consumption of content and increased revenue for their website. So just by increasing your user experience, by paying attention to these web vitals, you can actually see a better ROI. Here's another example from Yahoo Japan. They improved the CLS by 15%, and they got 13% increase visit duration. So some takeaways: do not insert content above existing content unless it's in response to user interaction. Provide a smooth and predictable experience. Content needs to shift in response to user interaction. Do so immediately. Don't wait for the network request to finish. For requests that might take more than 500 milliseconds to complete, use placeholders to reserve the space as the content loads. All interactive elements of the page, ensure that if it looks interactive, it actually is interactive. If you use server-side rendering, consider rendering your pages in a loading or disabled state, and then updating it when the JavaScript is active and fully loaded. So next I want to talk about something called SMS OTP, and it's related to one of the newer APIs that came to the browser, namely the SMS API. I'm sure you've probably been aware of seen this pattern before. Sign in and password. Sign in users in a process that to prove that the person is trying to sign in, the same person is the same person who originally registered on your website. And many websites choose to use passwords to do so. However, passwords are somewhat vulnerable. How many times we reuse passwords? So there are some challenges there. There are many traps waiting for your users on your website. Asking for additional evidence of ownership will help the user to prove their identity. So SMS OTP typically just requires the user to put a phone number, and then you would send a text message with some kind of one-time password or code. And then when the user enters that code correctly and you verify it, you can be sure at least the person who's talking to the website is the owner of that phone number. So this is kind of how it looks here. Enter the OTP because a user enters a username and password, and then sometimes use this for two-factor authentication. They would enter the normal credentials and the OTP, so you get that extra layer of security. Because users already registered their phone number on your website, the service can send an SMS message with an OTP. The user then opens the SMS app and copies that OTP and enter it to the form, so they will verify that, in fact, the owner of this phone is actually interacting with the site and you have authenticated the user. You could do other things with SMS OTP. For one thing, it is some way of verifying their phone number, and if it is you know that a user is tied to this phone number, you can do account recovery and even payment confirmation. So this is a nice video for a resource for even stronger authentication methods called WebAuthn, and it can actually tap into things like the fingerprint reader and the biometrics of the device if it's supported. So that's a talk there that kind of goes into those topics. So let's talk about some best practices for SMS OTP. Starting with general best practices on building a sign-in form. You can learn more on that through this article and the video from web.dev live. But today we will focus on specific tips on constructing an input field for an OTP. So if you're putting in a numeric, a number form, on a number text field on your form, you may be tempted to use the number attribute. However, that will give you this stepper, I don't know what you call it, like a drop down. It's an awkward number counter input, right? So instead of using type number, recommend using type text with the input mode numeric. And when you do that, devices would actually open up a keypad, which is just a little bit better experience for phones. And Firefox just recently started supporting it, so it works across browsers, as you can see here, including Safari. Now, another thing you can do for supported browsers is add the autocomplete this value to this autocomplete attribute. Right now, it's only effective in Safari, but as it helps the browser autofill, they strongly recommend that you put it there in either way. And what that would do is actually have the phone listen to relevant text messages and actually help autofill any values received. It will also help autofill the OTP code that's actually received on the phone from SMS. So you'll need to go across to the SMS app, copy and paste. So with the message that you're sending, there's a format you can align with to get the best out of the OTP experience. And the good news is that the same format works across Safari and Chrome. So you need to specify a bound domain, and the browser will assist the user entering the OTP only when the domain matches. Okay, so this is actually text message you send, and you want it to match. You want the domain or the origin given in text message to match the origin and the domain of the app the user is actually using. And by specifying OTP in the format, the browser can retrieve the exact OTP you intend to deliver and prevent the browser from picking the wrong numbers. So starting from iOS 14 and Big Sur, Safari will respect the format with the bound domain in the message and assist the user to enter the OTP. Chrome also uses the same domain bound text format, but with a different approach, which is called the Web OTP API. So this is how the Web OTP API looks like. Now, using the Credential Management API, the website can obtain the OTP via SMS as an OTP credential on a user consent and handle it imperatively in JavaScript. So you won't go into much of these details. This is just we can get an overall appreciation to the fact that there's an API that's doing this that works in the browser. So as soon as the user receives the SMS with a domain-bound message format, the dialog is displayed, and you can autofill the value by pressing the allow button. This is available in Chrome, Opera, and a browser called Vivaldi. They're hoping to see roll out with other vendors as well. So Tinder web app actually uses this OTP, and they found a 2.5% increase in OTP completion, as opposed to the user abandoning it. Another site, a hotel booking site called Oyo, reduced their time to login by 37%. Not too sure how to pronounce this. This is Guibibo. Travel booking service reduced sign up and retry by 25%. Other players like ShopPay from Spotify, Twitter, Facebook are preparing to bring this feature as well. So the adoption to OTP seems to be growing, and I think it's a really convenient way to let users to log in. So finally, when you're building the SMS OTP form, remember to use type text with input mode numeric and autocomplete one-time code. Remember the domain-bound message format for the SMS message, so the browser can get that code and know how to match the right code with the right app. So you can learn more from web.dev/SMS OTP form, or more about OTP in general by web.dev/webOTP. So next I want to talk about what's new for web apps in Google Play. So this might be strange because we all know Google Play as the App Store for Android. So what does web apps have to do with this? Well, there's this tool called Bubble Wrap. It's a CLI tool that lets developers use their PWA in an Android app. So it's somewhat similar to the hybrid approaches you've probably been aware of, like Ionic or Cordova. But Bubble Wrap relies on a different technology called the Trusted Web Activity. So they have made improvements to the tool, and now external dependencies are now downloaded automatically. So when you run the tool for the first time, so you know no longer it's an all-in-one solution or one click. You no longer need to download external dependencies and unzip files and type paths. There's also seen improvements in creating an application with more helpful description in the input fields and better validation. So this tool will take your progressive web app and actually compile it and build it into an APK, which you can then publish to the Google Play Store. Because one thing we are accustomed to seeing with apps is having some kind of app store to actually browse. So this could be a nice technique for web developers to get that additional audience to the web application by simply building it into an Android app and publishing it to the Play Store. And one other advantage is, well, Android apps can be open in full screen. So with Bubble Wrap, you can get a avenue for getting that experience as well. So with Bubble Wrap, you can specify whether you want to be a standalone display or a full screen. If you want to have a default, if you want the default look to be landscape or in portrait. Also, what's interesting here is that, well, users expect applications installed devices to have consistent behavior, right? So when you're asking for permissions on Android, it looks different for when you're asking permissions on web. So what Bubble Wrap is doing is making sure to hook into the native permissions model of the Android OS when it needs to ask for relevant permissions. So when inside a trusted web activity, the geolocation permission can now be delegated to the OS. And when disabled, users would see the same dialogues as, when enabled, users will see the same dialogues as apps built with Kotlin or Java, or find the controls to manage those permissions in a place that's familiar to them. So if your web app requires permissions for notifications and geolocations, everyone will know how to explore in the Android app settings where you change that. Well, those settings will also be accessible for web apps as well. So one advantage of trusted web activities, which is this, what they're calling this sort of hybrid of a web app wrapped into an Android app, is that it has a vastly smaller footprint. Remember, it's originally a web app and is meant for web browsers. So it needs to be really small and lightweight so it could be loaded for many users. So Bubble Wrap has been optimized and now generates binaries that are 800 kilobytes smaller. And that's less than half the size generated by previous versions. So it's actually really interesting. You can have these really nice lightweight apps running on different Android versions. Also, they have just added support for application bundles. So app bundles are smaller, little micro apps, if you will, smaller versions of apps, which Android developers could package the app to. And that's also available for Bubble Wrap as well. So as a developer creating an Android app, you'll need to update your app on the Play Store from time to time. Reasons might include using new trusted web activity features or changes to the Android ecosystem. So Bubble Wrap also provides tooling for making sure that you keep your app bundles or your apps, Android apps, up to date as well. Next, let's talk about next level web apps on desktop. So these days, web platform is becoming so large and robust, it could support many different features that we typically associate with native apps, right? This app is the Santa Tracker, and one of the cool things about it is that it gives a really nice experience on many different devices, on many different browsers. And that is the power of the web, to build once and get this wide reach of clients. And that's exactly the ability or exactly the feature that Gmail owes to a considerable extent its success to. It was just a website when it first started off. However, it has become possibly one of the leading email clients because of that reach, that universal reach it has on the web. No software install is required. You just need to have a browser, go to the URL, and you get this nice web experience. There's one. So, if you'll remember, for those who've been developing long enough, one of the major turning points of web was the dawn of this feature called AJAX. And it stood for Asynchronous JavaScript and XML. And it basically allowed web apps to request data and update the page or update the DOM without reloading the entire page. And that really transformed what was possible for websites. It's basically one of the things that allowed websites to be web applications and move and act like applications. AJAX was so transformational that in addition to enabling Gmail, a couple of years later, apps like Writely, that were the foundation of G Suite, came out. So similarly to AJAX, we're now seeing another transformational technology come to the forefront, and that is the PWA, or the Progressive Web App. And these are some of those features that the PWA, these are some of the new features that are now coming out that really take progressive web apps to the next level. And we're going to cover some of them. So because these are experimental features, right, they will not be enabled by Chrome by default. In fact, you'll need to go into something called the Chrome flags, where you opt in to trying out these experimental features. And then eventually, as Chrome updates roll out, these features will move from experimental to stable, and then will be available for all users. So first we'll look at the file handling API. Now, sometimes you have applications that you would want to open with other files. So if you have a CSV file, or if you have a Word file, that file would be associated with like Microsoft Word, for example. So we would also like to see that same kind of file handling or file association with web apps as well. And that's exactly what the file handling API lets you do: associate certain file types with your progressive web apps. And this is done by putting in this file handlers property in your manifest.json. And you also need to direct, well, which page or which action you're performing on the page to receive this file. And then in your application code, you will then describe how the page will handle that file. So it's somewhat like a file upload. So to access launch files, a site should specify a consumer for a launch queue object attached to the window. Launches are queued until they are handled by this consumer, which is invoked exactly once for each launch. With this approach, you can ensure every launch is handled regardless of when the consumer is specified. The application can then choose to handle these files however you'd like. So from this point on, you'll just treat the file like if it was a file upload from a phone. So next we're going to talk about two features at the same time, or at least back to back: tab application mode and display override, because they run hand in hand. Right? These two capabilities make sense to run together because display override will help us with tab application mode. First, let me show you what tab application mode looks like. Well, as the name would describe, is that your PWAs can have tabs. And that is really good for productivity-based applications. So here's how you use the display override member in a manifest file. Notice that we start with the widely supported display mode standalone. So remember, you have to be aware of what client the user may be using, and some features may or may not be supported. So in case it's not supported, you would use the widely, you would specify like a fallback called display standalone, and then use display override for that tab experience. So display override takes a list of display modes which are tried in that order. If not, it falls back to the next if it's not available. So it's going to try to do the tab. If tab is supported, it would work. If not, it's going to fall back to minimal UI and then standalone. Next, I'm going to talk about a feature called link capturing and URL handles. Link capture and URL handlers let you control what happens to the user journey once your app is installed in standalone or in tab browsing mode. So for example, a user should click from the browser that's inside of the scope of your application, open a browser tab or an existing standalone window. So maybe you have companion applications. Maybe you want to link to your application to a specific page from your blog. This is what link capturing lets you do. Instead of opening it in a new tab, if the user has your app installed already, it will launch that app from the OS. And that's done via the capture links member specified in this instance as existing client event. When the link is clicked leading to this PWA scope, now the scope it kind of refers to the origin, or it depends. The scope relates to the part in the path, the part in the URL to which it belongs to the PWA. Okay, so it'll be /home/whatever, based on how you build the app, whatever forms that path in URL, that kind of relates to the scope. We can see that in the define URL handles that you can see how origins are specified for handling with a wildcard. The permission for the app to handle URLs for these origins are then verified by the browser through a web app origin association file hosted in each handled origin. Next, I'm going to talk about the window placement API. Enables complex productivity apps that require multiple window layouts. So if you have used something like Paint.net or other drawing apps, you'll see they have multiple windows. So the window placement API kind of lets you emulate that feature. I'm not going to go into depth, really. I don't have a demo for window placement either, so I'm just going to move along. Another feature is run on OS login. Sometimes you want your app to be ready and waited in the background, or launch when the OS is started up and signed in, and you can do so with this API. But you want to make sure and let users opt into that. You want users to give control, over any behavior that might be seen as intrusive to the user. The other approach is via the API. You can specify the mode as either windowed or minimized for applications that should launch in a minimized state. Finally, I'll talk about the notification triggers, which is personally a long-awaited API from my end, because I've always wondered, how do I build a web app to then react to a certain time-based event without an internet connection? So notification triggers allow you to do just that. Allow notifications to be shown when certain conditions are met. And generically, the triggers can be time-based, location-based, or otherwise. But now we will look at time-based triggers. So this is code that you would put within your service worker. No, this might be in the window as well. Should work in either one. And basically all you're really doing is calling up the show notification API, but what instead you provide a timestamp. And then that when the browser is going to be listening on the time, and whenever that timestamp arrives, then the notification would show. And then there are more APIs to come. They're always rolling out new features. So these are some of the interested ones, like the Digital Goods API, local fonts, and the budgeting API. So next, I would like to go into some demos, demonstrate some of these things in action. I have a couple of PWAs that I would like to share with you all. So let me stop sharing my screen so I can. So first I want to show Excalidraw, which is a drawing PWA. Seems like these drawing productivity tools have a lot of, PWAs are very popular with these kind of tools. And as you can expect, you can install it as any program on the computer. So you click this button, install, and it'll open up in its own window. And what's really cool with Excalidraw, it actually uses the file, I won't say the file handling, but the disk API, file system API, which means you can write to files directly on your disk once you granted that permission. So if I were to do save, you would see here, can edit my file.excalidraw. And that's really cool because when I close off Excalidraw, I can reopen it. Open it from here and pick up directly where I left off because it's right into that file. Another one I'd like to show is the Scoosh web app. This is version 2, and it allows you to convert images into different formats. Install it here. And the Scoosh is a very nice use case and testament to using cutting-edge web features. It uses things like web workers to do conversions of images in a very performant way. And what it will do, it basically shows you, compare how an image would look when you apply different compression algorithms to it. So you can resize images, you could compress images to different formats. and then they will show you the before and after. Now you won't really see much of a difference unless you look really closely. But if we were to do something like reduce the quality, it may become more obvious. I can see it on my screen, but I'm not sure. And this will work offline. Well, assuming you install it first, of course. So these are some really powerful progressive web apps, and they really push the limits of what web apps could do. And with these new APIs coming out, those capabilities only grow. There's another one called Gravit, and it's yet another image designer. Let me see if I could log in here. And this is even using, could even detect when I'm using a touch device. So this is a touch screen, and they do have integrations to allow that, but it seems to be a pro feature, so I'll leave it as that. Okay. So these just are a couple of PWAs I thought I would share. And they're good demonstrations of what progressive web apps could do. So next, I would like to go on to the code lab, the last thing of the day. And here I'll be exploring the notification triggers API. Now, just a warning, this is somewhat, I would say, intermediate level JavaScript coding. So the point is to not to get too intimidated by the syntax, or not really. You don't really need to understand every line, but just get an appreciation for what we are attempting here. So I have this REPL website here, and it's a PWA as well. Notice the install button here, and it's a demo of the notification trigger. Now, in order for this to work, because notification trigger is still in Origin trial, you would need to go into Chrome flags and enable experimental web platform features. But what do I mean when I said Origin trial? If you go to this sheet here, which is the Fugu API tracker, you get to see the stages of which certain features are being brought to Chrome. And if you look here in the notification trigger API, you would see that it's now in that green section, and the green represents Origin trial. So that's scheduled to ship to browsers everywhere when Chrome 89 is released. Right now, the current version is 86. So these features will only be available behind it's said to be behind the flag. So you need to go into Chrome flags and enable the flag to use the feature. However, Origin trial allows developers to try these experimental features on their web applications and let users use these features without having them to turn on that flag manually. So what you would go to is Chrome Origin trials and register for a trial. You would then provide a URL which you can deploy your app to, such that when users visit that app on that app URL on Chrome, the flag for whatever particular feature you're registered for will automatically be enabled just for that website. So that's what the Origin trial is. It allows you to run experimental features to on websites or on applications for the users who's visiting your origin or website. Of course, links to these resources will be provided after the event. So if I go on Replit here, you can run a test notification. And see a test notification pops up. If I do here, I can try the notification trigger at this countdown. And then you'll see that notification automatically trigger. So let's see how this is done. So this is the markup using a library called Materialize. If I go in my script, I just have some vanilla JavaScript code for starting that button. This is to turn on notifications. So you notice for this website, I don't ask users for your notification permission as soon as they visit. They need to opt into it, and that's kind of what you typically want to do, because notifications can be seen as an intrusive feature. All right, but the main functionality is happening here is this create schedule notification. And what you need to do is get the registration from the service worker. So once you have a PWA that's installed and running, you would have this service worker global scope active, and you can get something that's called the registration, which is somewhat like an object that gives you access to the service worker APIs. Then you call show notification, but then you provide this object called a timestamp trigger. And this notification is set for 10 seconds. So I just get this timestamp, the current timestamp, and add 10 seconds to it, where 10 is the offset passed to this function. For completeness, I can also look into the service work itself. So in a PWA, you need 3 things really, or 4 things. You need, first of all, it needs to be saved on HTTPS. Okay. You need a manifest.json. Manifest.json has certain properties that are needed by the browser to render things like the icon, and more about things like the multi-window and whatever other features you would want for your PWA. This is the icon, standalone. This is the scope. The scope isn't declared here. This is the start URL. This indicates what is the first URL of the app. And then you need a service worker. And I'll also provide links to how you write a service worker and what have you. But minimalistically, in order to get the install banner, now Chrome requires that the app needs to be able to be run offline. So you can't just have a service worker and a manifest. You need a service worker with that offline capabilities. And that is achieved by doing something called pre-caching. Pre-caching is when you tell the service worker what are the files that make up the website, and then store those files into the application cache. So if you go over here, you can see the service worker is running. But also, if you go into the cache storage, you can see this cache of files. So these files all are stored in the browser, and that's because I programmed the service worker to do just that. And because it's stored in the browser, this app is available offline. So if I go in service worker and put it in offline mode, should be able to reload the page and it will still work. Can test the notification, still work. I could do a countdown. 2, 1, still work. And this is a powerful feature that I've been longing for, because now we can do something like an alarm, or if it is, I know a user won't always have an internet connection, but I want to be able to fetch data in the background and update like a data cache. And I know at a particular time in the day they would have a connection. I could then schedule that kind of update in the background on a timely basis. So notification triggers are used for that, but they're useful for that, but they also provide other kind of triggers such as geolocation, but we won't really be exploring that right now. So this is the pre-cache. Next, you want to do, this is where you set up the pre-caching. So you have an install event. When the service worker is first visited by the browser for the first time, this event will fire. And here's where we just tell the pre-cache, create a function, an asynchronous function, and then send caches.open all of the files you want to cache. Add all the files and then retain the cache, and then pass, it's a little weird syntax, but then pass that function call to this event.waitUntil. So you're basically saying, as part of the installation event, I want to run these commands, which is take these files and put them into the cache. What I have down here is a little bit more complex, and this allows for runtime. I would say, I think it's called runtime caching as well. So there are two kinds of caching in a sense. Pre-caching is storing files before, and runtime caching is storing files as you request them. So these are not all the files needed for the website. If you go here, you'll notice that the cache storage is a little larger. Things like Materialize is needed, my fonts and what have you, but I did not specify them here. So how does that work? Well, essentially, I just told the service worker for every request made on the page to cache the response. So I don't want to go into all of this now, but you can see it basically here. You just need to respond to the fetch event. So every time a page makes a request, this fetch event will be invoked on the service worker. And this is where the service worker could somewhat step in and interject for the request and do other things. Right? So when a fetch request is made, I'm going to tell the service worker to run this function called cache first request. And this function is all about checking for the request in cache. If it's a resource that we already have in cache, then we don't need to ask the network. If it's not in cache, it's going to ask the network, but then put it in cache afterwards. So that's what all of this code is doing here. So we check the cache for the request. If it's there, well, we can just return that cache response. Else, we need to actually make the request and then cache it. But if that request is 4.4, maybe the app is offline and it's not in cache, then we need to give like an offline page. And if this breaks, maybe the page is offline and, sorry, this is just offline, but this is offline and not cache. So if there's any error at all, we just return the offline page. Okay, and this is a minimalistic PWA. However, you don't really need this one for the install. You just need the pre-cache really, but I always like to add the runtime caching as well. And if it is you don't want to learn all of this syntax, the service worker syntax, which you can do and use instead, is a tool called Workbox. Very nice library that would auto-generate your service worker for you. So it can generate the pre-caching service worker for you without needing you to write any code. It will detect all the files on the website. One thing to note with service workers is because it's all about caching and pulling up files that are there before, you need to think about how you invalidate the cache, what happens when you do make revisions to these files and you need the browser to throw away the old versions and update the cache. That's done using this static cache name. Anytime there's a change to the cache name and it's detected by the service worker, so let's do a reload. The service worker will notice that there's a new version of service worker and then attempt to install it. Now it's saying this skip wait and stuff, and that's because there are different ways you can program the service worker to act to a new update. The default way is that when the app is closed and then open back, it would use the new version. If you want it to be more aggressive, you can programmatically run this skip waiting so that immediately the new service worker has taken control of the pages. Okay, so that's about it for CodeLab. Three slides. So in wrapping up, we covered to a light extent some topics that were discussed in Chrome Dev Summit. Chrome Dev Summit was held just a couple of days ago on December 9th and 10th, right? And of course, those sessions are available for viewing individually on YouTube. So we talked about some UX patterns for optimizing for Core Web Vitals, SMS OTP. How do we get apps on the Play Store? And what are the new groundbreaking features coming to PWA's desktop, more specifically desktop PWAs, because you don't want to do Windows stuff on a phone, window management and what have you. To find more information on CDS, you can go on Google on this site here for the agenda, links to other resources and what have you, and links to other extended events like this. As I said before, you could get the CDS sessions from the Google Chrome Developers YouTube channel. And look out on our blog for this post-event post, okay, where we will give you all the links that you have seen today and more. And finally, if you are not already been joined on the community, on the new community platform, I encourage you that you join and register for GDG Port of Spain so you can get further updates on further events and what's happening in the community. So that's about brings us an end to our mini event today. I know 2020 has been tough for all of us. But hopefully in the new year, there's hope of seeing new things and more events. But thanks for sticking out with us this year. And we hope to have more, fun and exciting events in next year to come. As a matter of fact, in January, be on the lookout. We may be having another event very soon. So that's it for today, and see you in the next one. Bye.